Our immune system is equipped with cells that form an army that help our body defend itself and fight foreign invaders. Some of these immune cells, called T cells and B cells, are programmed to get rid of foreign invaders like viruses and bacteria. T cells release toxins against the foreign invaders, and B cells make antibodies to neutralize them. We have known for some time that our immune cells can recognize cancer cells as foreign invaders and attack them by secreting special factors or weapons. How can our immune cells do this? The organs of our body are composed of billions of cells. These cells contain thousands of proteins that act like worker bees and are responsible for the function of our cells. These proteins break into small parts called peptides. Some of these travel to the surface of our cells and are presented by molecules called MHC or HLA. T cells continuously scan the surface of these cells through the T cell receptor or TCR. The TCR works as a barcode scanning machine, and the peptides presented on the cells are unique barcodes. This function of the T cells is called surveillance. If T cells recognize these peptides as normal, then the T cells move on. But if the peptides come from foreign invader proteins, then the T cells get activated to attack the invader cell with weapons to eliminate it. The T cell secretes certain proteins and chemicals called cytokines and factors. These molecules punch holes into the cells that contain the invading organisms. Proteins are your body's basic building blocks. They allow your cells to divide, rest, and function properly. But sometimes these proteins get changed or mutated. For example, smoking leads to mutations that make abnormal proteins in our lung cells. Sometimes when these proteins are changed, they stop functioning normally. This makes the cell become cancerous by making it grow and divide to become cancer. These mutated proteins are also broken down into smaller pieces and are presented as peptides on the surface of the cancer cell. These abnormal peptides are recognized by the TCR as foreign and activate the T cells to kill the cancer cells. But if the immune system can recognize and eliminate cancer, then why do people develop cancer? Sometimes the immune system fails to do its job. The immune response against cancer may not be strong enough, or cancer cells may evade the immune system. Tumors, or a group of cancer cells, can build a defense network against our immune system. These defense mechanisms can either prevent the immune army from entering the tumor or can weaken and inhibit the T cells. For example, tumors can express attack molecules on their surface that bind to the T cells and inhibit their killing activity. These molecules are called checkpoints, and examples are PD-1 and CTLA-4. The tumor can also secrete proteins, factors, and cytokines that inhibit T cells from attacking and killing cancer cells, and can also turn the T cells into friends of the tumor. These cells can then deactivate other T cells. These traitor T cells are called T regulatory cells and are the enemy of the killer T cell army. The field of immunotherapy has shown great progress toward a cure for cancer, after working at it for many years with some major recent breakthroughs. Immunotherapy is actually one of the most important revolutions in the history of medicine. What are the different types of immunotherapy? Immunotherapy functions in two primary ways: by enhancing the immune system and making them stronger, and by using drugs that help inhibit the suppressive immune environment of the tumors. One enhancement method is to create vaccines. Foreign antigens can be identified by identifying mutated proteins in the tumor. These mutated proteins, called neoantigens, can be given as a cancer vaccine. The cancer vaccine is developed to activate the patient's own T cells against the foreign antigens. Like the flu vaccine fights against the viruses, the tumor vaccine fights against the foreign tumor cells. Now that the T cells are trained by the neoantigen vaccine, they go around the body to find those specific mutated antigens and will locate them on the tumors. Another enhancement approach is adoptive T cell transfer, where T cells are taken out of the patient's body, grown in the laboratory, and educated to recognize cancer or even modified to become much stronger. These fighter cells are then transferred back into the patient. A third enhancement approach is using stimulating factors called cytokines. Cytokines are stimulating proteins like interleukin 2, 7, 12, and 15 that cause the T cells to significantly multiply and get stronger. A fourth enhancement approach uses agonist antibodies such as anti-OX40, anti-GITR, and anti-4-1BB, and others to cause the T cells to grow and strengthen. This allows the enhanced T cell to overwhelm the cancer cells. A second approach to immunotherapy. Strategies have been developed that knock down cancer defense mechanisms. There are antibodies that neutralize the inhibitory factors and cytokines such as anti-IL-10 and anti-TGF-beta and IDO inhibitors. Some of these approaches have already been approved by the FDA, like anti-PD-1 and anti-CTLA-4. For example, patients in this clinical trial have melanoma, a kind of skin cancer. 50% of people with advanced melanoma die in 12 months until recently. Patients were treated with antibodies against both CTLA-4 and PD-1. Growth of the melanoma tumor in different patients was recorded and plotted out in a graph. The growth lines show that targeting both CTLA-4 and PD-1 encourages T cells to fight cancer. With this combination approach, 70% of patients with advanced melanoma continue to survive more than 3 years. These therapies also have some side effects that need to be monitored very closely by the treating physician. Although the side effects are not very common, they could be life-threatening if not treated. These side effects are treatable, especially if discovered early, which include diarrhea because of inflammation in the intestine, include some endocrine diseases that lead to weakness, thyroid dysfunction, or diabetes, and other side effects that need to be discussed with the treating team. The future of immunotherapy is in combining different approaches to accomplish two goals: to create a trained army of cells to attack the cancer, and to break down the defenses of these cancers by unleashing your own immune defense against cancer to improve on the currently very impressive results that immunotherapy is already providing our patients.